それでは時間となりましたので始めたいと思います。ヨハネスさんによる The Good and Bad of Modern App Architecture のセッションです。それではヨハネスさんよろしくお願いします。
Thank you. Thank you. This talk is the good and bad of modern app architecture. Now, of course, modern needs definition, but if you have seen the talk's description in the app, then you know what you're up for. So my name is Johannes. Just one moment. So my name is Johannes. I started Android development 10 years ago in the beginning of 2009, when in Germany, that's where I'm from, the Android market was first introduced. And I'm still continuing to do that. 2 years later, in 2011, I founded an Android-only company called AndLabs, Android Laboratories. And we did client work. We worked for many companies, large and small, most prominently BMW, but also like German television companies, maybe most people of you don't know. Then, in 2016, 2.5 years ago, I moved to Japan, to Nagano City. And in the beginning of last year, I joined Fast Retailing. I joined as an Android architect, and in the meantime, I also became the dev lead of the whole Android application engineering team. So who of you knows Fast Retailing? More than I thought. So Fast Retailing actually is the third largest apparel company in the world. We have many brands, 8 of them, but like these are the smaller ones, but most prominent are GU and UNIQLO. So who of you knows UNIQLO? Yeah. So usually when I talk to people and say I'm from Fast Retailing, they're like, what? And then I say UNIQLO, and they say, UNIQLO, I love UNIQLO. And so UNIQLO and GU are by far our biggest brands. And what do big brands like UNIQLO need? They need apps. Of course, they need apps. And we have them, at least 2 versions. So in some markets like Indonesia, Malaysia, and until this week, Australia, the app looks like this. So not the most modern design, very limited in functionality, and not so nice and representative for a modern brand. That's why it had to be redone. And what we came up with was this. It's a little nicer. Was done by an external company, an agency, and has some issues. Maybe you can already see there is no, I can't go away from here, right? So there's no, go here anyway. So there's no separation of layers, no shadows or anything. So material design is so-so. And also here's a view pager indicator, and here's another one. So it's a nested view pager, which is not so nice for UX. But there are also other issues. Maybe you've seen it. So if we take a closer look, so this and this, these 2 bottom navigations are totally different. So on the left, we have a home screen. On the right side, we have the menu button, and so on. And the reason is this one is native, and this one is not. So most of you are probably native Android developers, so you know the user experience that comes from web wrapper applications is usually not as good as native. So long story short, at some point it had to be redone. And that's when I joined. So I was the first Android architect, first Android engineer in the company. And for making the new app, we had many challenges. So I was the first one. So we had to be able to onboard new engineers as the time went on. We had to move from 90% web to 90% native. We had a special requirement that we knew we had one server endpoint with its data structure, and we knew we had to change it to another one while developing. And also, like I mentioned, we have not only UNIQLO, but we also have other brands. So we needed to make reusable components so we could support UNIQLO, GU, and other brands, and so on. And this was especially true for the data layer. Long story short, we decided to go with clean architecture. Probably some of you have heard it. So it was introduced by Robert C. Martin or Uncle Bob in 2012 and has been more and more adapted to Android. Usually it has layers like this. In the middle, in the center, is the entities. Entities in this case doesn't mean database entities or API, like web-related entities, but enterprise business rules. So the business rules that are true for all of the enterprise, not only one application. Then the second layer, that's where the application business rules are, the domain or use case layer. The third one is the interface adapters. This one contains the presenters, the view model, the views. Usually most of the MVVM or MVP goes here, if you have that. And it's also responsible for converting formats that are useful for the data layer, database, web, to formats that can be used by the use cases, and vice versa. And then the most outer layer is frameworks and drivers, which contains things like data classes, web drivers, and so on. There's also a dependency rule, which goes like this. Layers from the outside can know layers on the inside, but not the other way around. So this means, for example, use cases, the business rules are not allowed to know anything about its environment as in the Android platform. This means if you take use cases, you should be able to run them in any JVM context, not only on Android, but also on your server, or wherever. And now rules of the patterns you use inside the structure still apply. To make it more clear, like this, so the different participants inside of the layers should not know each other. Single responsibility and so on applies. So that's the theory. Here's how we did it. Where's this coming from? I don't know. Anyway, so this is how we did it. I added some animations later on, that's why. So that's the data layer. We call it data manager. Data managers are responsible for deciding where to get data from. For example, check the cache, there's nothing, then query the local database or API. Usually in an Android context, we call this repository. But the repository pattern was used differently, has a different meaning initially, so it's a little overloaded. And the iOS developers got confused, so we decided to name it Data Manager. So we generally tried to have a similar architecture between iOS and Android for some reason. We also generally chose MVVM to have, because MVVM now is famous on Android, or at least supported by Google, so most new joiners know it, so it's easy for us to onboard them. Yes. So data managers also have mappers. They transform data from the local database or web into something that's actually usable by the use case or the main layer. Use cases know nothing. They just have themselves and interfaces to talk to. And their entities is something we called, or the data structures is something we called business model. Use cases responsibility is, like I said, business rules. So for example, in our case, if the use case would be show a product's detail, including inventory, then the use case would say, okay, for this, I need to query the product data manager and an inventory data manager, then get the data, combine them, and hand them out to my output port. Then view model, probably everybody's familiar with view models by now. Uses the data of the use case, talks to it using interfaces, holds the UI state, handles user input, and if necessary, transforms data into something that's usable by the view. And the view then, now it makes sense, represents the view model state. And then in the end, we also used, of course, dependency injection to glue everything together. In libraries, this looks like this. So in the data layer, we have object box for persistency. That's a non-relational, not non-relational, NoSQL database. We have retrofit for querying our REST API. RxJava to do data streams because Rx is also available on iOS. That's why we chose this solution here. No live data. Use case, again, have only plain Kotlin and Rx. Then view models use RxJava data binding from the Android, provided by Android, and lifecycle components, so Android X.lifecycles view model. Ideally, this part should be platform independent, meaning, again, we could take it out into our whatever Java runtime and run it there, and also easily unit test it. And that's the part that's most important for me, actually. Then the view also uses data binding, and then we have some view libraries like the ones we get from the platform, of course, and also Lottie, Groupie, and some things from the Android X packages. So that's the general rules, and of course, when there are rules, usually they get broken, and in some cases we did it intentionally. So like I said before, we have many applications, and we have to support them from the data layer. So we have, for example, the UNIQLO application, then we have another application, app 2, app 3, and so on until application N. So the data layer had to be reusable. Now, ideally, in a clean architecture environment, the use case defines and owns everything it needs. So in this case, the use case can say, I need this repository or data manager, and it should have this return format for this function. And then the data manager implements the interface. However, in our case, the data module should have been separated and should not know about use cases of specific applications. So we could not do it like this. So we decided to give the ownership of the repository interface to the data layer, closer to the data layer at least. Another thing, you probably saw it before. So I said this one should be ideally platform independent, but if we look closer, data binding and Android X lifecycle packages are not platform independent. And for the benefits we get by having data binding and lifecycle handling in our view models, we decided to go with this and having it not completely independent. However, we can still unit test them easily. Now, we use Dagger. Who of you is kind of proficient in Dagger? Nice. We also use architecture components. Anybody? Nice. RxJava, of course. Anybody? Okay. 100% Kotlin, because we did it from scratch, so I mean, I don't need to ask. Retrofit. It's easy. Objectbox. Yeah. It's kind of new. Jetpack. Yeah, probably, no? And also Mockito for testing. So, and who knows all of them? Exactly. So one of the issues we actually have is if somebody joins our team right now in February, talking to some of my team members now, it might take them 5 months until they really say, okay, now I'm getting it. So one of the bad things actually we introduced by having so many components, like external components, libraries, is that the onboarding cost is high. Maybe not too high, but high, definitely high. Another thing I don't really like is this. So a data manager has its own entity, and a use case uses the data manager, but it also has its own entity, and it should not know anything about the data manager. So far, so good. But also, as I explained before, our data managers should not know about the use cases because they need to be reused. So how did we solve this? Of course, interfaces and generics. So we have a generic interface. We have a simple interface that's used by data managers and defines input and output generics. Looks like this, for example. So from to, receive this format, return this. Super easy. I did this actually. What could possibly go wrong? So issue is, our data managers are closer to the API than the application, which means usually the one data manager represents many endpoints and has different return formats. For example, we would have one for product lists, one for product details, one for the whole product taxonomy tree. Then maybe the data format for a different product type, like recommendations, would be a little different, and so on. And then by having only one return type and this mapper, and using it everywhere, we end up with data managers like this, which has product list mapper, product detail, product pickup, taxonomy, and so on. And this can be really hard to use and really hard to write and maintain. Another thing, use case, scope. What's a use case? So that's a question we asked ourselves, and we made a decision. So a use case could be one screen. And one screen could be like this. For example, if you have a product, trousers, you have a product image, you have colors, you have add to favorites button, you have the name of the product, you have the description of the product, you have an add to cart button. If you scroll down, then you also have the availability, the inventory in your store, and then you have some recommendations. So if you do decide, like us, to have the scope of one use case be one screen, then this is really a heap of code. It's like super large view models and super large use cases and gigantic test suites. That's the bad. Then another one. 2 years ago, I was here in another room, but at this conference, and saw a talk by John Reeve. It was about readability and meaningful tests. So I saw this. Then, like 2 or so months in the project, I remembered it, checked the slides again, and thought, yeah, that's great. Let's do it. So I changed what we had from this to that. So on the left side, before we had, for example, product use case, then we switched to convention SUT for system under test for the tested entity in unit tests. And from really no particular structure, we went to a given, when, then structure, which is a little behavior-driven development-like. And then from being readable only for us programmers, we changed it, or wanted to change it, to be readable for normal human beings without special abilities. So we went from something like this to this. So for the given statement now, it reads like, given that a fetch product call will return a test observable. So like a English sentence. And for then, it's now, then a subscriber to system under test should receive a test product without errors. So I did this, then I made documentation for this, made like a guide how to use it. I changed our biggest test suite to this pattern. It was great. Issue is, it doesn't work. Or it didn't work. Maybe it does work, but it didn't. Reason being, for one, our team is very international, and the English proficiency and correct grammar is not necessarily given. So having natively readable English sentences is not always the case. Second, the cost of education when introducing a new paradigm in an ongoing project is too high, and I would have needed to invest too much resources of myself. And also introducing a new custom library, like this given that part, that's something I wrote and wrapped around RxJava, and this then a subscriber to, that's around Mockito, is also too high. Cost is too high. And then we have lots of layers in comparison, maybe. So maybe if you started, probably your first application was activity, access, data. Or maybe even web if you started early. And now, of course, we have layers. We have the view, we have the view model, we have the data, the use case is the data layer. And in some cases, we have some of these layers are kind of empty. So simple use case just requests data and gives them to the view model without anything like merging streams or something like that in between. So some developers, especially the ones that are still in the 5 months phase where they don't know what's going on, say, why do I have to write so much code? I always did it this way. Why do I have to do it that way now? And of course, young developers just want to make it work, and then they say it works, but what's the issue? Why do you reject my PR? You know. Okay, that's the bad part. So we also had some good things. So often, so in my career 3 times I've experienced this, something looks like this. So in the beginning, you have an architecture, it looks nice, you have high maintainability, you have no bugs or little bugs. Then the pressure increases because the release comes closer. So you get like, okay, just make a workaround here, it's okay, like accept. It's okay, like business side is happy, that's fine. Bugs go up, maintainability goes down. And then there's the handover. The team leaves. Maybe external team, like UNIQLO is not a tech company. They did their job, party, leave. Another team takes over, doesn't know why this is there, introduces more bugs, maintainability goes down even more, and in the end you have an unmaintainable mess and you need to make a new product. So far I've been on the left side once, on the right side twice. And for us in our case, thankfully, it looked like this. So we had pressure coming closer to the release. Our maintainability went down a little, we had some bugs, but after release, we have been able to kind of get back to normal within about 1 sprint. Another good thing, so we have the separation of concerns, and we are able to, in theory, work on each layer separately. So one developer can work on the view, one can work on the view model, one on the use case, one on the data layer. Now, of course, there will be conflicts to some extent, and there needs to be communication between the developers. But generally, this is how we scope our tasks, our Jira tickets. Also, I spoke about tests. So use case and view model are usually, generally, the logic in view models and use cases is tested. So it might not be the most pretty test, but your logic is tested, and this gives me as a developer a very nice feeling. And then last but not least, in December last year, we finally shipped our product. So to our Canadian test market. So overall we had challenges, of course. Nothing is perfect. Nothing is ever perfect, I guess. But it's still okay. Now I have a challenge for you. I want to see somebody who can prove me that it's possible to be onboarded in less than 5 months, maybe 4. So if you think that's you, why not apply, join my team, and help us make the UNIQLO user experience even better. So it's a large company, but still they're so new to tech, especially the leadership, that we as developers can still have a large influence on the mobile future on all levels. And like even if you're from overseas and want to relocate to Japan, it's no problem. We give you the visa, we pay you the flight, just come here, do it. Okay, that's all from me. Thank you for your time. And I think you can ask me questions somewhere outside. Thank you.